Hello students, I hope you are all doing well. Welcome to another video by QuickStudy. In this video, we will continue the first chapter, States of Matter. In the previous video, we learned about the characteristics of the different states of matter, which are solids, liquids, and gases. We also learned about the interconversions between the different states and the processes through which they take place. Therefore, in this video, we will now cover the remaining part of states of matter, which are diffusion and solubility. So let us get into diffusion. So what is diffusion? Diffusion is the spreading of particles in a gas or liquid from an area of high concentration to an area of low concentration. For this to work, the particles must be able to move freely. Therefore, diffusion is not able to occur in solids since the particles are fixed in their positions. The particles in solids are only able to vibrate in their fixed positions. So let us take a look at diffusion in gases. Diffusion in gases can be shown very easily using orange-brown bromine gas. The diagram shows this experiment. The lower jar contains bromine gas while the upper jar contains air. When the lids are removed, the brown color bromine gas particles diffuse upwards while the air particles diffuse downwards until there is an even mixture of brown. The bromine gas particles and the air particles move at random to give an even mixture. So both gas jars contain an even mixture of brown colored bromine gas and air particles. Gas particles travel at different speeds depending on the mass of the particles. Therefore, let us take a look at a diffusion experiment that shows how particles of different gases travel at different speeds. The diagram shows the experiment. This can be shown by the reaction between ammonia and hydrogen chloride gases, which reacts to form a white solid called ammonium chloride. From the cotton wool which is soaked in aqueous ammonia, ammonia gas is produced, while from the cotton wool which is soaked in hydrogen chloride gas is produced. The ammonia and hydrogen chloride gases diffuse along the tube towards each other, and where they meet, a white ring of ammonium chlorides form. The ammonia particles are lighter, they have lower molecular mass, and the hydrogen chloride particles are heavier. The ammonia and hydrogen chloride gas particles diffuse along the tube and move towards each other. A white ring of ammonium chloride forms where the two gas particles meet. Ammonia particles are lighter, they have lower molecular mass than the HCl particles. Therefore, the ammonia particles move faster and travel further than the HCl particles. Therefore, the white ring of ammonium chloride forms closer to the HCl end than to the ammonia end. The equation below shows the reaction that takes place. Now, let us move on to diffusion of liquids. Diffusion of liquids can be demonstrated by the diffusion of potassium manganate in water. The crystals of potassium manganate is placed in a jar containing water. When the potassium manganate crystals dissolve in water, a purple solution is formed. The potassium manganate particles diffuse from an area of high concentration to an area of low concentration. So the particles, the purple color of the solution, moves upwards until the color is evenly spread out throughout the water in the jar. The diagram below shows how the whole process takes place over time. Diffusion in liquids is slower than diffusion in gases because the particles in a liquid are more closely packed together than the particles in gases. Therefore, the particles in liquids are able to move more slowly than the particles in gases, and therefore diffusion occurs slower. Now, let us move on to solubility. But before we dive fully into the topic, let us first explore the important definitions that is required for understanding this topic. So, what is a solvent? Solvent is a liquid in which a solute dissolves. What is a solute? A solute is a substance that dissolves in a liquid to form a solution. Solution, on the other hand, is a mixture formed when a solute has dissolved in a solvent. A saturated solution is a solution in which no more solvent can dissolve. Now, what is solubility? Solubility of a solid in a solvent at a particular temperature is usually defined as the mass of solute in which must dissolve in 100 grams of solvent at that temperature to form a saturated solution. So this takes us to solubility curves. So what are solubility curves? Solubility curves show how the solubility of solids changes with temperature. The diagram below shows how the solubility of potassium nitrate and potassium chloride changes with temperature. Any mass below the line for a solute at a specific temperature would mean the solution is unsaturated. On the other hand, any mass above the line for a solute at a particular temperature would mean that the solution is supersaturated and unstable. Generally, the solubility trends are as follows. Solubility of solids increases when temperature increases. On the other hand, solubility of gases increases when pressure increases, and solubility of gases decreases when the temperature increases. So now, let us take a look at some problem exercises. In this question, we have to use a solubility curve to answer the questions. The first question is as follows. Determine how much potassium nitrate will dissolve in 20 grams of water at 50 degrees Celsius. So to answer this question, from the graph, we see that the solubility of potassium nitrate at 50 degrees Celsius in 100 grams of water is 68 grams. Therefore, in 20 grams of water, by using unitary method, we find that it is 13.6 grams of potassium nitrate that will dissolve. So the answer is as follows. The solubility of lead to nitrate at 90 degrees Celsius is 118 grams per 100 grams of water, as we see from the diagram, and solubility at 40 degrees Celsius is 64 grams per 100 grams of water. Therefore, per 100 grams of water, a saturated solution of lead nitrate is cooled from 90 degrees Celsius to 40 degrees Celsius, 54 grams of crystals are formed. Therefore, 200 centimeter cube of solution, the mass of crystals that will be formed is 108 grams. With this, we have come towards the end of this video. Now let us do a quick recap of what we learned today. We learned what diffusion is and how diffusion of gases take place using the orange-brown bromine gas experiment. We also learned that gas particles travel at different speeds depending on the molecular mass of the gas molecules. We also learned how diffusion in liquids take place through a demonstration of diffusion of potassium manganate crystals in water. Finally, we learned about solubility and what solubility curves are and how they are used to find the solubility of solids at different temperatures. Thank you for watching this video. If you liked this video, do consider subscribing as we post regularly on different subjects and topics regarding the GCSE syllabus to help you ace your exams. For more information on our online one-on-one tutoring services, do visit our website www.quickstudy.uk. Thank you.